All right, today we're going to go ahead and talk about solution composition. Now, with solutions, we typically talk about the liquid um, solution where you have a liquid, or sorry, things like sugar water, seawaters, clear things that have liquids in them. But this just gives you some other options. And here you've got the state of the solution, the state of the solute, and the state of the solvent. So, for example, air is technically a solution, and a solution is really just a homogeneous mixture where you can't see the parts and pieces. Even brass technically is a solid, but it's a mixture because if we could melt it down, then we would separate out those particles. Okay, so if we think about composition, a few definitions that kind of go really back to simplistic things, but you've got solute, which is the substance that's being dissolved. The solvent is what is dissolving the solute. And when both are liquids, typically the one with the larger volume is going to be the solvent. So in other words, if you think about dissolving, things are really just being surrounded by something else. So if something's both liquid or even both a gas, whatever has the larger volume is going to be the solvent. Whatever has the smaller volume is going to be the solute. Okay, now there are a couple different ways to describe solution composition. And the most important one still is going to be molarity. The other three I'm going to show you. We're not going to see a ton of it, but I'm going to show it to you anyway, just in case we need to know it. And if we have 1 gram of ethanol, do some examples to just show you, is added to 100 grams of water to make 101 milliliters of solution, which both of these, we're going to end up with 101 grams. They're both going to have about 1 gram per milliliter for density, so that's where we're going to get 100 mils of solution. We're just going to find all of them. We're going to find the molarity, mass percent, mole fraction, and then the molality, okay, which is a little different. All right, now molarity is the number of moles per liter. Same molarity we've been dealing with all along. Here's just your grams to moles conversion. Here's your milliliters to liters conversion. So we end up with 0.215 molarity. We've got capital M, which again, remember, can be moles per liter. Same thing we had way back in with solution stoichiometry that we all love so much. Okay, mass percentage is just a mass percent of the solute divided by the mass of the entire solution times 100. Notice it's not solute over solvent. Solution is the total here. Ooh, not quite sure why I'm so shaky there, but all right. So anyway, here's your mass of the solute is 100 grams here. Then we've got what would be 101 grams down here. We multiply by that 100. Now remember, when we do percentages, even though in the past we had said 2 sig figs, you still want to use your data. So because you have 3 sig figs in all your data, we're going to have 3 sig figs in our final answer. Okay, mole fraction, we saw it with gases. Remember, mole fraction is just this funky little X. You've got the moles of whatever the part over the moles of the total. Okay, it doesn't matter however many parts and pieces, but down here is your total moles. So here's again your moles of your ethanol. Here's just the molar mass conversion for water, plus your moles of ethanol. We get 0.00389. You could use sig figs, scientific notation, but remember the one thing about mole fraction is that there is no unit. I know that's very different than what we've seen in the past, but for all of most of our other quantitative calculations. Okay, molality. This is different. This is moles of solute per kilograms of solvent. Okay, not grams, but kilograms. And we have to have, maybe going, really? Why do we have to have all these different versions? And the reality of it is so that we have a unit to fit whatever states that we're dealing with. So that's where if we have moles per kilogram, this may define something that's a solid as opposed to a liquid. So that's where this is going to come in as well. But we can still do the math. We've still got our moles of ethanol. Just instead of our grams of solution, it would be kilograms of solution. And actually, this is wrong. This should be solvent, not solution. Because if it was solution, it would be 101. So it's your kilograms of solvent, and that should be solvent. It's written correctly. And with molality, it is a lowercase m. Molarity was that uppercase m. Molality is your lowercase m. As long as it's big and small, it's good enough for me.